So we're going to look at function notation in our introduction to the idea of functions. So you can think of a function as a machine with input and output. That's the idea of a function. So there are multiple ways to represent to any kind of a specific function. We're going to look at two ways. We're going to look at a graph, how to represent a function by a graph, and how to represent a function by a table. So again, a function has an input and an output. So you can think of this as a machine, and the input values that we're going to use in example 1 are here. So let's say if I input -2 into the machine, it does whatever it's going to do. It does a transformation, and it's going to spit out 4, let's say. So we can represent this idea in a table. I'll call this function f of x. So the input is my x value and the output is my y value, and we know that y is equal to f of x. So I input a -2, and the machine spits out a 4. If I input a -1, the machine spits out a 1. So I'll record that on my table, and I'll keep doing this. Okay, in goes a 0, and let's say the machine spits out a 0. We put in a 1. Let's say the machine spits out a 1. We put in a 2. The machine spits out a 4. Okay, so that table is a representation of a function. Okay, and what we kind of say maps to, that's some of the language you'll hear me, That's some of the language you'll hear me say. So we say that the input maps to the output. -2 maps to a 4. 1 maps to a 1. 2 maps to a 4. 0 maps to a 0. Okay, so that's some of the language we're going to use. The domain, that's going to be the name of the stuff that we put into the function. So the domain is the set of all possible inputs into the function. You can also think x values, especially like on a graph or whatever. So all of those words highlighted in blue, domain, input, x values, those are all synonymous. We're going to kind of use those interchangeably depending on the situation. So the domain is the set of all the things you put into the machine. All these terms in green are also similar. We're going to say what you get out is called the range. The range is the set of all possible outputs of the function. So whatever the function spits out as a result, that's going to be called the range, and you can think y values. Function notation looks like this. F of x equals y. So we notice that the entire expression f of x really means y, by like that whole cook of stuff means y. That's why we say it's equal to y. All right? So that's how you got to think of that. That f of x is actually y. X is just the inside part. If I ignore this stuff, right? The x is just what's inside, but when I write f of something inside, that's the y value. Keep in mind that that notation does not mean parentheses, does not mean multiplication. It is not f times x. I know parentheses usually means multiplication, but in this context, it doesn't. So I have that little study tip over there for you. It's important to note that this does not mean f times x. This little expression here, if I were to say what it means in words, I would say the name is f. We're naming our function. The name of the domain, so the domain or the input is the x. So you say of, f of x. The name of the function of the domain is equal to the range. So this is your domain or your input, and what goes over here, that's your range or your output. That's how you have to think of a function domain, of a function notation. The idea or the concept of function is so important because that's what we have kind of in everyday life. We see functions all over the place. One example is speeding tickets. If you get pulled over for speeding, there's a function machine that they have that they put your speed that you're going, however fast you are or however many miles per hour you are, over the speed limit. That's the input to the machine, and the machine spits out the fine. Now, something that's important about functions is when you put a certain input in, if you put that same speed in, if you keep putting that same speed, let's say you're going 75, every time you put 75 in the machine, it better spit out the same output. It can't sometimes spit out a $100 ticket and other times spit out a $200 ticket. That would not be fair. So a function is used to describe a lot of things in our world. So if I'm going 75 miles per hour, the function that figures out the ticket better report out the same range every time. It better print the same ticket. It's not fair if some people go 75 and get one ticket and other people get a different fine. So that's the idea of function. Let's see if we can apply this domain and range idea. So when I say what is g of -1 equal to, remember g of -1, this whole expression taken together really is equal to y. And they want to know what is y equal to. So it's like me saying y equals what? And what's inside of the function here, that's our domain, or that's our x value. So what they're really saying is, what is the y value when x is -1? So this question conceptually is really easy once you understand the notation, right? If this were back in 7th grade, I would just say, what is the y value when x is -1? I would write that question out. This is notation that means that. So I go to my table, I look for -1. Wait, I don't see a -1 in the x column. Why is that? Because the name of the function is also important. I'm supposed to be looking at function named g, and I'm on the table for the function named f. So I've got to go to the function g, I locate -1, and I see what y value -1 maps to. -1 maps to 3. I can't write this in green on top of the green. Go with, let's see, go with white. All right, now let's look at g of 5. So if I go over to the table named g, I look down the input value, or the x, for a 5. I locate 5 and see 5 maps to a y value of 0. So you're going to pause the video here, and you're going to see if you can go all the way up to h. Don't do I and j yet, just stop at h. Okay, so welcome back. Here are the answers. You should pause the video again and see and check your answers. Okay? Right, so let's look at this other question here. Actually, before we do I and j, let's go over here and do some challenge questions. What is 2 times f of 3? What does that equal? So the 2 is just really a 2 times. We're going to find out what f of 3 is. So again, if I understand the function notation, f of 3 represents a y value for the given x value 3. The f is important because it tells me which table to use. So I go to the table f, I find my x of 3, 3 maps to -1. So I know that f of 3 equals -1. So since this y, remember that represents y, is equal to -1, I can place a -1 in its place. And now I'm doing 2 times -1. Now here is where parentheses means multiplication, because I don't have like a letter f in front or a g in front. So this actually does mean 2 times -1. We get -2. So 2 times f of 3 is equal to -2. I'm going to make a couple more of these and see if you can do them. You can pause the video. I'm going to make a couple, write them down, and then pause the video. Let's see if you can do g of 0 minus 3 f of 1. That's number 1. Number 2, let's see if you could do g of -1 squared minus 4. Let's see if you can do f of 4 minus g of 2. And lastly, let's see if you could do f of g. Oh wait, let me check number 3. That probably won't work out. Yeah, sorry. I'm gonna do a plus here to make sure it works. And then finally, let's do f of g of negative. Nope, let's not do that. Let's do. That's interesting. Let's do 0. F of g of 0. Pause the video, see if you can get those. Okay, so let's check your answers. So g of 0 minus 3 f of 1. G of 0, let me do this, I need some more room to write this stuff down in our challenge problems. G of 0, that means I locate 0 on the G table, maps to 1. So I take this out and I replace it with a 1, minus 3 times f of 1. So I go to the f table, I look at 1, 1 maps to 2, is 2. So since f of 1 is 2, I take that out. So you can see I have G of 0 minus 3 times f of 1. That's what I rewrote. Now it's multiplication and subtraction. So I have 1 minus 6 equals negative 5. All right, let's look at this next one. G of negative 1 squared. So whatever G of negative 1 is, when I get it, I'm going to square it and then subtract 4. So I've got to look inside here and figure out what G of negative 1 is. So if I go to the table for G, negative 1 maps to 3. So I can take this out of here and put a 3 in. And so 3 squared is 9, so I get 9 minus 4, which equals 5. This one I got f of 4 plus, now I've got to put in here, I got to start, you always kind of start inside. So what is G of 2? I go to the table on G, G of 2 is negative 3. So I can take this out and put a negative 3 in its place. Now I got to do the 4 minus 3. So I have f of inside of here, 4 minus 3 is 1. So now I have to do f of 1. I go to the table for f. Let me erase some of this stuff. I look at locate the x value 1, and that maps to 2. Okay, these are like higher level, harder questions on SATs for function notation. What if I have a composition here? That's what this is called. It's a new operation that we're going to talk about more in class. We've got G of 0 plugged inside of f. It's like a nested function notation inside another function notation. So what we're going to do is we're going to work from the inside out. G of 0 is 0 maps to 1, so I get f of 1 now because I take out the G of 0 and I replace it with 1. And now I work on the f of 1, so I go to the table for f, 1 maps to 2, that's our answer. Okay. Now let's take a look at these two questions over here. All x for which g of x equals 3. So remember, g of x represents a y, like that whole thing there means y. So what question is this? This is the reverse question. In these guys, they were telling you x, remember x is inside there in the parentheses, and asking you what is y. Now they're giving you that y equals 3, and they want to know what's the x inside there that would make y equal to 3. So I go to my table for g, and I'm looking down the y column now, and I see a y value of 3 right here. 3, what mapped to 3? Negative 1 is what mapped to 3. So I say x equals negative 1. And you have to write it out, x equals. Now we're going to look for all x for which f of x equals 2. So I go on, again, f of x, right, is the y. So we're saying, like, if y is 2, what is the x value that causes that to happen? So if I look at my f of x table, I notice y of 2 happens twice. So it's okay to get 2 answers when you're going backwards. So x equals negative 3 and 1. That's where the y value equals 2. So that's how you do these guys. Let's look at, what if I give you 2 graphs instead of tables? What does that mean on a graph? If you understand the x and y notation, right? F of 1 means y, so they're saying what is y equal to? And the x is what's just inside, if I just look at this. So what they're really saying is when x is 1, what is y equal to? This f is important because it's got to name the function so we know which one to use. So when the x value is 1, I go up, I find the function, I look over, and I see it's got a y value of 2. Let's look at g of 1. So again, it's saying what is the y value when x is 1. So if I go over to 1 on the x, I go up till I hit the function, I look over, it's also 2. Pause the video here and see if you can get ahead and only go up to part H again. Okay, you can stop at H. All right, so you can pause the video again here and check your answers. Okay, let's look at these guys now. This is the same question. They don't know the x, so they're saying what is the x value that gives you a y value of 1? Remember, this means y, all this f of x. So they're saying y equals 1. What is the x that produces that? Of course, the f is important because it tells us what graph to look at. It's naming the function. So if I look on function f, and I find 1 on the y-axis this time. So I go here, I see a 1, and I look left and I look right and see, do I ever hit the function? I actually hit it twice. I hit it here when x is 0, and I hit it here when x is 3. So there's two answers for which that happens. X equals 0 and x equals 3. Okay, all x for which g of x equals 0. So now we're on g of x, and they say g of x equals 0. Remember, g of x represents the y. So I find y 0 on the y-axis, and it looks like it hits the graph here and hits the graph here, and it's already right on the x-axis. So it looks like it's at 2 and 1, 2, negative 3. Oops, I wrote negative 2. 2 and negative 3. All right, so now we're going to do some practice on your own and see if you understand.